Greetings of the day. This is Team Odyssey from VIT Bhopal University, and our problem statement comes under the Group 2 Topic 2, that is basically unveiling interconnected patterns and hotspot in synergized landscape dynamics, economic growth, and environmental data for informed decision making. Our team members are Anirudh Kumar, that is myself, Akshit Srivastav, Nikhil Mathur, and Nayasha Rai. As you know, these problem statements tell us to unveil the hidden patterns through diverse machine learning approaches to develop a robust relationship between land use and land cover and gross domestic product. Integration of atmospheric and geophysical data is also essential to obtain comprehensive correlation across all datasets. The developed model should output spatial temporal hotspots and trends concurrently from multiple datasets, with focus on anomaly validation and further in depth analysis if needed. Brief about our approach, we are basically generating getting our data collection from Bhuvan's LULC dataset and IMD's rainfall dataset, RBI's GDP, and this process involves converting raster data to CSV through vectorization, where we are allowing isolation of each LULC feature. QGIS and Restereo library are then employed to gain deeper insights into geotiff and explore associated statistics. Data anomalies are addressed through data visualization using these libraries. Over a further analysis, we are using authoritative government documents for research and statistical validation. And in case of model training, we are using TabNet, linear regression, and as you can see on this table. Now, if we go in the detailed proposal and solution approach, then we have data collection part, then data pre-processing, visualization, further analysis with authorized data sources, model training, unveiling data patterns, identification of hotspot, result visualization, anomaly validation and further analysis, iterative optimization, at last documentation and reporting. This is the workflow of our project where we have given the data set from the Bhuvan platform in which we have LULC, rainfall and annual GDP. In LULC we have done vectorization. Then through vectorization we have obtained shapefile. In the shapefile we have various classes. We have combined all these classes according to the area. For example, if we have these red classes a lot, then what we have done, we have basically combined all these red classes to a single entity and obtaining total number from 55 lakh of rows to only 17 features, that is 17 rows. Now, from here, we have calculated all the statistics that can be done, and through the statistics we have obtained the percentage of the area, because whatever will be the 2012, 13, 14 uh, features, it will always be associated with the percentage increase of that particular area. Now through that we have added it in the CSV dataset. Now in the rainfall dataset we have 356 slash 366 band for the leap year respectively. So for the day wise band, we have associated temporal mean, and for after day wise band, we have converted it to the spatial mean and then feature for that particular, which is basically annual rainfall for that particular uh, feature. That, and then we have added it for each year in the CSV dataset. Then we have obtained annual GDP for India, on which the base year is 2004 and 5, and then we have added it in the CSV dataset. Further analysis in the CSV dataset, we have rainfall, the time that is 4 years 2014, 15, 16, 17, then LULC 17 features, and then GDP. Over that, now we have the new dataset, and these dataset we plan to perform data analysis, algorithm modeling, and deployment. In the data analysis, we have done the Pearson correlation, and according to that, we have used data validation. On first iteration of this particular process, we got to know that even though UP is 42% around uh, agro-based economy, the Kharif, Rabi, and Zaid crops are quite less in that particular area. So then again, we have obtained the 2016, 17, 18 data from the Bhuvan platform, and then the same process was utilized, and again we got here until you get a good data. Then we have used data validation in case of data analysis and various model algorithm, and then found out the relationship conclusion for LULC, GDP, and rainfall. And then we have deployed this in the app. So if we move here, this is some of the data visualization that we have done. In this data visualization, you can say the current fallow, that is in red, is whenever it is increasing, the Zaid and Rabi crop is decreasing, which means while Kharif crop is irrespective of these current fallow, which means that in the case of Kharif season, people are still using the land, whereas in Rabi and Zaid season, people are leaving that land as it is. That's why percentage of that particular area is quite less compared to our. And then here we have plantation and GDP increase. On a general analysis, you can say plantation is directly related to the water bodies of max, and it is quite related to the rainfall also. When we go to the code part, we will see how it is related. Now, this is the hotspot prediction using rainfall and LULC. We have predicted for 4-year month-wise prediction of hotspot. That is 2012, 13, 14, 15. You will get every single month from January to December, in which you can visualize how the rain is increasing and decreasing. After that, these are the tools that we have used, and these are the technology that have been involved. These are the references, and these are the web application and YouTube explanation. This is for the presentation. Moving towards the code part, first, we have this data visualization, in which, if you observe, we have data visualization for each crop, and then a conclusion is here. This is the conclusion, and this is the observation. Moving forward, we have water bodies minimum and maximum with the plantation, its conclusion. And then we have scatter plot for various crop season, which is basically for the forest and the wasteland and their correlation. Then we have this percentage for the grassland. After that, this is the water bodies minimum maximum with plantation, and then scatter plot for the crop season. Then, using the QGIS, we have obtained all the rainfall data and then used it to observe each particular hotspot. And similarly, if we move for the code part, we have also used tabnet algorithm, linear regression, and we have also used this multi-layer perceptron, LGBM regression, regression, in which we got to observe that SVM is giving us the best cross-validation score, and hence we are getting our data points as a best in this support vector machine, and the relationship is quite robust. But for a conclusion, we would like to conclude that as we got more data, we got to observe that the correlation for each particular area is being enhancing. Hence, it is telling us that as we get more data, the correlation for each particular area will increase more and more. And thus, the GDP will be there. And that's why Kharif, Rabi, and Zaid crops will be more highly correlated compared to this evergreen forest, which is zero point 0.7. That's it from our side. This is from Team Odyssey signing off. Thank you.